Now it's time to introduce the two trigonometric parent functions that we'll be using a lot in this chapter, called cosine and sine. And we've been using these before, but not in a graphing sense. So I want you to think about the transformations that we used to do with functions like the x squared function and the square root function and absolute value of x. Those were parent functions, just like these are parent functions. They have a basic shape, which is not going to change unless you do something to it, called a transformation. And I've written a general form equation right here, and that shows you the types of transformations that we typically do. That k value, for instance, right here at the end, that's called the midline, okay? And I can write it as the equation of a midline because it's a vertical shift, okay? That is how much that you push the graph in the vertical direction, up or down, depending on whether it's plus or minus. Okay, so that works the same way as the vertical shifts that we saw in previous chapters. And we'll get into some of these other ones later, like phase shift. We're not going to talk about this one very much right now. That involves a horizontal shift, left and right, just like we used to do shifts left and right with the other parent functions before. These other two we are going to use a bit. There's amplitude, right, A, and that is how much you stretch this curve up and down. So if I multiply by A, what that's going to do is it's going to take my cosine curve here and it's going to stretch it like this. It's going to get taller. And if I look at this last thing we have here, what do we got? B. B is a horizontal change. Now, if you remember, when you have horizontal transformations, they act weird compared to the vertical ones. A horizontal shift, for example, it goes left when it's positive, it goes right when it's negative, right? Everything's kind of backwards. Likewise, when you have a horizontal scaling factor, that's what the B is, it's a scaling factor. If B is greater than 1, like let's say we had B equal 1/2, okay? You might think that's a compression, a shrink, but because it's inside the parentheses, it's operating on X, everything's backwards. So actually, it would stretch our curve like this. Okay, it would make it longer in the X direction. And that's just going to take a little time to get our heads around, but we'll get there. What it would look like in this picture is, the curve would be, way stretched out like this. It would be really long. So those are the four types of transformations. We're not going to deal with the phase shift immediately. We're going to get to that a little bit later. But that's what's coming. Now, I've drawn here the parent functions, cosine and sine. And you can see I'm labeling some key points, A, B, C, D, and E. Those are very useful when trying to figure out what the graph of the function looks like. See what I've drawn here in this image is a dotted line. And that shows you where the parent function lives. But really, the sine function and the cosine function are trigonometric functions. They're called periodic because they actually go on forever. Forever and ever and ever. All the way down to infinity in X and negative infinity going the other way. Okay? We don't typically worry about that because if you can show me that you know the pattern for one cycle like this, that's enough that I know you get the idea. Now, as to why it goes on forever, that's kind of interesting. I think there we are. There's our good old unit circle. Remember how the angles go around and around and around and around, etc. You can go forever if you want. You can figure out the cosine of 3,000 degrees if you want. And it repeats itself over and over and over again as you go around this circle. That is what we're talking about as you go down in X. So those circles that I was just drawing on the graph, those are the angle theta as it goes down the x-axis. We've talked about some of that in class. Now let's get to the points. These 5 special points on the cosine curve that I have here, you can just read them off the graph, right? X equals 0, y equals 1. X equals pi over 2, y equals 0. X equals pi, y equals negative 1. And if you notice, imagine plugging some of these values into the unit circle, or maybe you've memorized your cosine values. That would be really helpful, actually. If you notice, any one of these x values that you plug in here, let's pick 3/2. Okay, if I said, what's the cosine of 3 pi over 2? Well, you might remember this one. That's going to be 0. And you can see that on the graph right there. Okay, so that's how the cosine parent function works. And the sine parent function is down here. Again, the same thing. If you know your unit circle, this should be a cinch. 0, 0. The sine of pi over 2, well, that's just 1. The sine of pi, that's 0 again. Sine of 3 pi over 2, that's negative 1. And the sine of 2 pi, that is 0. So we're back to where we started. So you see that both of these parent functions have, I guess, what we could think of in terms of a length. How wide is this little graphing window that I just drew there? What's the length of that? How far does it go in this direction? And you can see that for each one, the length of that box in x is 2 pi. 2 pi is very important. That's how far around the unit circle you go before you start repeating yourself. Well, these are periodic functions, and we like to talk about what the period is of each of them. The period refers to how long it takes to go through a complete cycle of this sine wave, this sinusoidal function that either starts at the top for a cosine curve or at the middle for a sine curve. Now, the period is calculated as 2 pi divided by b, where b is that scaling factor, the horizontal scaling factor right here. Okay? So that's the only one of these where you actually have to do a little bit of math. Most of the other key features, you can just look at the equation and say, oh, there's h, there's a, and so on. But for the period, you do need to calculate some numbers. We will get into more about stretching and transforming these parent functions in later examples, but for now, I just wanted to go over the key points and concepts.